Factor the trinomial completely. 10x squared minus 35x minus 20. Now the first best idea when you're factoring a polynomial is to find and factor out the GCF, the greatest common factor. And to do that, we first do factor trees on each of the terms. There are 3 terms in this trinomial. We're going to create a number branch and a variable branch. The number 10 splits to 2 times 5. The x is x times x, the x squared I should say. In the next term, and we're going to disregard the 2 minus signs of the terms for the time being. We want a number branch and a variable branch. The number branch splits into 5 times 7 and then times x. For the 20, we have 2 times 10 perhaps, or 4 times 5. It won't matter. In the end, you have 2 2's times a 5. Now, we're identifying the greatest common factor, and they have to be factors that are in common with each of the 3 terms, and the 2 only appears in the first term. It doesn't appear the first and the last term, but it doesn't appear in the middle. So 2 doesn't go in the GCF, but I see that a 5 is a common factor across all across all 3 terms. So we can put a 5 in the greatest common factor. Now I'm looking at the next unique factor. We looked at 2's, 5's. Now we're looking at x's. X appears in the first 2 terms, but not the last. 7's, I hop over to the other factor tree. 7's appear in the middle, but not in the first or last. And we've already looked at 2's and 3's, everything that's in the last term. So we can confidently say that I can use either a GCF of 5 or GCF of negative 5. With definitely a GCF in this polynomial. Now, the other thing that's nice to do after we do a factor tree, the red step factor tree analysis, is to make a clean copy of the original polynomial. 10x squared minus 35x minus 20 is the original polynomial that we're being asked to factor. And now we're going to be able to, now that we found the GCF, we're going to write it out to the left. We're going to start by analyzing the positive version of the GCF and see what kind of interaction we have, mostly with the first term. Now here's the GCF is going to be factored out of 3 terms. We want the first coefficient of the first term of this remaining polynomial to be positive. We want this is a positive symbol. We want the first term to be positive. So we're trying to make the GCF, the 5 times this first term, make this 10x squared come back. The 10x squared is positive, and if this is, we're forcing it to be a positive because it's easier to deal with positive leading terms, then this GCF, between the positive or negative version of the GCF, we're going to choose it to be positive. That's what makes the final decision on what sign of the GCF should be. So positive times this positive makes this positive come back. Now we move on to what else should be in this blank so that 10x squared comes back. And what it should be is 5 times 2. And there should also now, in other words, 5 times 2 makes 10. There should also be an x squared in this blank. So let's check it. Positive times positive makes positive. 5 times 2 makes 10. And there's also this x squared regenerates this x squared in the first term. Now we're going to move on. We're going to distribute this positive 5 to this middle term so that positive 5 times everything we need to put in here makes negative 35x come back. So let's work out the sign first. Positive times negative makes negative. 5 times, I would need a 7 here, so that 5 times 7 makes 35. I also need an x to appear here. 5 times, let's check everything, make sure we have it. Positive times negative is negative. 5 times 7 is 35. And x needs to be in this blank to make this x come back. Now let's distribute the positive 5 to the last blank, fill everything we need in so that 5 times this blank, everything in this contents of this blank, make negative 20 come back. Positive times negative. I have to have negative so that negative comes back from multiply. 5 times, I would need a 4 here, so that 5 times 4 makes 20. Now we have the opportunity to say, ask ourselves, could we continue factoring this remaining polynomial? We have to try. What it is a trinomial, and we can run through several ideas here. It's a trinomial that we have left here. Can we continue factoring? So we look, first of all, there are 3 kinds of trinomials. There's perfect square trinomials, where the first and last terms are perfect squares. This is not a perfect square, and neither is negative 4, so we disregard perfect square trinomial. The next kind of trinomial has an x squared plus bx plus c form, but the first type has got a 1 here, and we definitely don't have a 1 here, so this type of trinomial, if it's factorable, falls into the type of trinomial, quadratic trinomial, where there's some number here in front of the x squared that's just not a positive 1. What we're suspecting is that we have an ax squared plus bx plus c type trinomial, but let's verify all the parts. We have a variable squared in the first term. We do have that. We have a number, here's this a. The other part is a is some number that's just not a 1. We have some number that's not a 1. This is a 2, so that fits the pattern. The variable that's squared in the first term, does it appear in the middle? The variable that's squared in the first term, does it appear in the middle to the first power? Yes, it does. X is squared in the first term, appears to the first and the middle term. If we put a plus in to match this plus, then b is negative 7. We're slowly able to identify all these parts. Do I have a constant at the end? Yes, I do. If I put a plus in to match this plus, in other words, instead of minus positive 4, we say plus a negative 4, we are able to identify c. So do we have this form of a trinomial? Yes, we do. So for this type of trinomial, the method of choice, the method of factoring, the method is the AC method. We should use the AC method, also known as factor by grouping method. And I'll describe these now as we go. The AC method. Well, the AC method asks us to draw 2 tables. It wants us to identify the factors of the number that we get when we take a and times by c. So a is positive 2 and c is negative 4, which gives us a product of negative 8. We're looking for the factors of negative 8 whose sum is b. b in our case is negative 7. So we're looking for 2 numbers times each other that make negative 8, and the same 2 numbers added together to make negative 7. So when we think about the factors of negative 8, you know, there are several combinations that involve 8s and 2s and 4s. If I consider negative 8 and positive 1, after all the combinations, does this combination work in the other table? So let's see. Negative 8 times positive 1 makes negative 8. Yes, these numbers work in the first table. If I owe someone $8 and I only have $1 to pay them back, I come out owing $7. This combination of numbers works. They satisfy both tables. So the way we use these numbers now in the factor by grouping method, or the AC method, is we take our, let me go back to red, we take this, let me clean it up too. we have 2x squared minus 7x minus 4, and we can't leave the GCF behind. So we're going to take these magic numbers that many people refer to as P and Q, and we're going to split the middle term. We're going to split the middle term into two terms. While, of course, we're holding the other two terms, all the other two terms, this first term stays at 2x squared. The last term stays at negative 4. We're working between these parentheses. This GCF is also part of the final answer. We can't leave that behind. So now we take our magic numbers. I call them the magic numbers because they help us complete the problem like magic. We drop them in here for the in these spaces. I put the 8 in the space next to the 2x squared. 8 and 2 have a factor in common. That's going to help us when we go to factoring by grouping. And then we put the other magic number, positive 1, in the other blank. Now, these numbers, everything we put in these blanks have to add back up to negative 7x. So we place x's next to these numbers. Then proceed. I'm going to move everything we have up to here. And I'm going to go into one color now for the time being. 2x squared minus 8x plus 1x minus 4. Because at this point, the AC method is done. The AC part of this method is meant to split the middle term into two terms. Now that we have a 4-term polynomial, from here down, all we're going to do is factor by grouping. Factor by grouping is the method of choice for 4-term polynomials. So factor by grouping asks, just in the first two terms, can we find factors that are in common? And I see a 2x in common. What would be needed in these blanks? 2x times x makes 2x squared. 2x times negative 4 makes negative 8x come back. The next portion of this with my technique is to copy this binomial that remained after we factored out the 2x. Just copy it under these last two terms. So we have an x minus 4. Now, of course, look, we're working in between them, upgrading to brackets. This 5 is still out here. We're doing factor by grouping of the 4-term polynomial inside. Now, what we find out is that this x plus 4 and this x plus 4, they appear twice. What I'm looking for, though, is what would we have to place in this red blank so that this times this make positive 1x come back. And we already have the x factor. We need a positive 1 in this blank. Positive 1 times x makes positive 1x. Now distribute this 1 to the negative 4. Positive times negative makes negative 4. So it's working. We were able to find something that completed the pattern here of making the original 4 terms in between the original red parentheses come back. Now, what we see is the x minus 4 actually is a GCF of its own. It appears in two places. And the numbers, since it appears in two places, we open up two blanks. First time we see x minus 4, it's multiplying a 2x. Second time we see x minus 4, it's multiplying a positive 1. If we were to distribute this x minus 4 as a binomial to each of these two terms in here, the underlined terms, we would get these two big terms back. This 5 is a greatest common factor that is part of the final answer. We now have, I don't see any other factoring that we could continue toward, and we could rearrange it. We'll either see it this way, or around the multiplication dots we could have 5, rearrange the 2x plus 1 factor, and then the x minus 4. We're just rearranging around the time slots, which the commutative property of multiplication allows us to do. And if we were to FOIL these together, I'm going to leave the check step up to you. If we were to FOIL the two binomials and then redistribute the 5, we should get our original polynomial back that we're being asked to factor. The factors that I look for appear in this way. It looks like to me that B is the correct answer choice. It has all the proper components of 5, a 2x plus 1, and a factor of x minus 4.